Welcome back to the workshop. We want to take a look at an example using the properties of trees. So let's say we have a collection of houses in some primitive community, so there aren't roads that connect all of the houses, but we want to create trails between the houses. Okay, it's a bit of work to create a trail, so we want to create as few trails as possible. So the question is if there are 6 houses in this community, how many trails need to be built? Well, of course, this is the section on trees. So we want to recognize that what we have is the situation where we are trying to have a graph that's connected with as few edges as possible. And so to do that, we want to recognize that we are looking at if each house is a vertex, each house is a vertex, then of course we are looking for a tree. And when we're looking for as few edges as possible to have a connected graph, this type of graph that we're looking for is a tree. All right. By a theorem that we've already taken a look at, so by theorem 5.1.3 of the notes, there will be exactly how many edges, right? So if we have 2 houses and we want to get from one to the other, we're going to travel along a trail, right? And so if each trail is essentially connecting one house to another house, then when we look at these trails, we are moving from one vertex to another along an edge. So the trails are the edges. So we have a theorem that tells us about how many edges there are going to be in a tree. A tree with n vertices has exactly n-1 edges. So if we're looking at 6 houses, we're looking at 5 trails. So there will be exactly 5 trails. So if I wanted to, for example here, so I've already answered the question. There's going to be 5 trails. If I wanted to, I can take a look at the houses just to see how I might connect them. So if I call this house 1, house 2, house 3, house 4, house 5, and house 6, then I could have a path from 1 to 4, from 1 to 2, from 1 to 6, from 6 to 3, and from 6 to 5. That's one example of how we could do this. Okay, cool. That's 1, 2, 3, 4, 5 edges. Now, maybe I want to create some shorter trails, so I go ahead and I make them connected in this way. That's fine too. Or maybe I don't like that. Maybe I don't like that it's just one big line, so I go like this. That's fine too. There are a lot of options. However, I can't do this, right? It's not connected and it contains a cycle. I could do this. That's similar to what we already had once. Right? There's a lot of different ways that we could create these trails between houses. But if I want to create as few trails as possible and still have all the houses connected to one another, there needs to be exactly 5 trails made. All right, so it's considered bad luck to live at the end of a trail. Oh no, bad luck for number 2, 4, 5, and 3 here. So it's considered bad luck to live at the end of a trail. So can we actually create trails to be so that way there's no house that's at the end of a trail? Well, if we look at this within the context of graphs, when we look at our graph, here's an example where 4 houses are at the end of a trail. Okay, so we think of it not as maybe not as each edge is a trail, because then every vertex would be at the end of a trail, right? Every vertex is at the end of an edge. But what we mean here is that it doesn't continue on. I can't come to the house and leave it along a different trail. I can't continue on. I'd have to go back the same trail. So here we're looking at the idea of a vertex having degree 1. So again, so no, it's not possible. And that's by another theorem that we've taken a look at. So by theorem, let's see, take a look back. Here we are. In a tree with more than 1 vertex, there are at least 2 vertices of degree 1. So there's going to be 2 houses at the end of a trail. So by theorem 5.1.2, let's see here, every tree of, let's see here, every tree with more than 1 vertex has at least 2 vertices of degree 1. That is, at least 2 houses will be at the end of a trail. Excellent. So that's all that we wanted to take a look at. All right, there's an additional comment down here. Feel free to read that. You should have the notes. So again, we can take a situation, observe it as a graph, and then recognize that the situation we're looking at is also a tree, and then use the properties of trees to answer some questions about the graph of interest. All right. That's the end of section 5.1. So that's all that we have for now. So thank you for your time and attention. I'll see you guys again a little bit later back in the workshop.